Density is how something is spread out in space. You're used to mass divided by volume being density, d, or Greek letter rho. So it would be in grams per cubic centimeter, or kilograms per cubic meter, or something like that. So the density of water is 1 gram per cubic centimeter. So if you had 10 cubic centimeters of water, it would have a mass of 10 grams. So it's easy enough to do conversions. If you know the mass and the density, you can find the volume, and so on. But the mass doesn't have to be spread out over a volume. If you had a rope, you could talk about the mass per length. We usually give that a Greek letter lambda. And so that's in, say, kilograms per meter. If 100 meters of rope has a mass of 5 kilograms, we would say 5 kilograms over 100 meters, or 0.05 kilograms per meter. If you had 5 meters of this rope, if 5 meters was the length, the mass would be lambda times L. You would have the mass would be 0.05 kilograms per meter times 5 meters, and you'd get 0.25 kilograms. Likewise, we could talk about a mass per area. You could talk about a sheet of metal and say, all right, how many kilograms is this per square meter? How many grams is it per square centimeter of material? And so it would be a certain thickness. Mass divided by area is sometimes called surface density. It's two-dimensional density, and it has units of, say, kilograms per square meter, and the symbol is a small letter sigma. Regular mass over volume is rho, mass per length is lambda, and mass over area is sigma. So these calculations are not hard at all. It's just about as simple as a unit conversion. You just need to know that they're out there. Lambda, sigma, and rho stand for mass per length, mass per area, and mass per volume. So density, in terms of mass, how it's spread out, could be spread out in 1, 2, or 3 dimensions. But mass is not the only thing that can be spread out. You can also have population density, how many people there are per square mile. If you had an area that was 5 miles wide and 4 miles long, you know that would have an area of 20 square miles. If you had 10,000 people living in that area, then your population density will be 10,000 people over 20 square miles, and that would be 500 people per square mile. Population density isn't that strange an idea either. So it's not just mass that can be spread out. Population, people can be spread out. Energy can be spread out. You can talk about the energy density inside a car battery, right? People building electric cars want to make the system more compact. They want a higher energy density. And people designing systems care about the energy density of the fuel, right? They need the most energy that they can fit into the smallest volume so that they have more leg room or whatever when they're designing an electric car. Just as mass can be spread out in a line over an area or in a volume, electric charge can be as well. Now, electric charge usually has the symbol Q, and it is measured in units called coulombs with an abbreviation capital C. So we can talk about the charge per length if you had an electrically charged wire. Charge divided by length is lambda. We're reusing the symbols that we use for mass density in 1, 2, and 3 dimensions. Charge per area, by far the most common one you're going to encounter. Q over A, sigma. So that's going to be in coulombs per square meter. And if you ever had to talk about a volume charge density, it's hard to arrange because they all repel each other, so you'd have to have these charged cubes or something and stack them up and keep them from pulling apart. Charge over volume, Q over V, is equal to rho. So that's coulombs per cubic meter. Now, as I said, the most common example you're going to see, and maybe the only one you have to deal with, is charge over area is sigma. So if you have a surface that is electrically charged, there's going to be so many coulombs worth of charge in a square meter. Now, realistically, it's going to be microcoulombs, nanocoulombs, or even picocoulombs, because a coulomb is a lot of charge. Finally, we have particle density, which you encounter in chemistry and sometimes in physics, as in diffusion. Particle density is how many particles you have in a volume. Now, you could measure the number of particles in moles or individual particles, small n or big N. And the volume you can describe in cubic meters, cubic centimeters, liters. So if you have moles per liter is molarity from chemistry. It's the concentration. Concentration is number of particles per volume. So as you can see, there are several kinds of density, but they're all related. They all mean the same simple concept, how something is spread out in space. You take the amount of stuff you have and you divide by the total length, or the total area, or the total volume, whatever you're spreading things out in. And that's the idea of density.